An Airbus 320 uses a fly-by-wire system, meaning that the wings are electronically controlled using DC motors. In this video, we will be teaching you how to create a model version of this fly-by-wire aircraft. Using a joystick, we could run two motors independently. They can move in the same direction or in the opposite movements. If we look at the wings of an airplane carefully, you'll notice that there are ailerons at the outermost and spoilers at the innermost. To demonstrate what does it mean for a pilot to move the joystick of an Airbus 320 and what would the wings respond, let's look at this video. If he moves the joystick to the left, the airplane would make a counterclockwise tilt because of the ailerons, where the left one will move up and the right one will move down, and a slight left turn because of the spoilers on the left that are being raised up, hence the spoileron effect. In a similar manner, when the joystick is being moved to the right, the left aileron will go down and the right aileron will go up. Additionally, the spoilers on the right side will raise up. The overall vector force for this Airbus 320 in this mode is that it will make a clockwise tilt and a slight right turn. When the joystick is being pulled backward, the airplane would pitch up. In a real Airbus 320, it's the elevator that will move up, not the flaps. But for the sake of demonstrating the wing movements, we will just imagine the ailerons as elevators. Since they're at the middle of the airplane, these ailerons would move downward, like flaps. Hence, flaperon mode. Ailerons acting like flaps. This creates an upward pitch. The elevators actually move upward at the back of the airplane. During a downward pitch, when the joystick is being pushed forward, the elevator at the tail will move downward. But for the wing's sake, both ailerons will move upward. Ailerons now acting like spoilers in spoileron mode. Since both ailerons are being moved upward, the spoilers on both sides of the wing will also move upward. Here's the mechanism behind that joystick in 4 directions and their wing responses. As you can see, when the joystick is being moved forward or backward, both ailerons will move correspondingly. But when you move the joystick sideways, the ailerons will move in opposing directions, where one would go up and the other one will go down. It sounds like a confusing direction of the ailerons. Let's simplify the functions. That's the simplified motor circuit, where only one aileron will move up or down, and in this case, the joystick will be moved on the corner, northwest, northeast, southwest, or southeast, not anymore northeast, south, or west. This makes it easier for us to create a fly-by-wire system for a model Airbus 320. We have also simplified the wing design for this model. We only have 2 ailerons and 2 spoilers. When the airplane is being pitched upward and turned to the left, as well as tilting counterclockwise, only the right flaperon would move down. No other wing elements will move. When the pitch is still upward and the tilt is clockwise and you're making a right turn, the left flaperon will move downward and no other wing elements will move. But when you pitch downward, make a counterclockwise tilt and a left turn, the outer left spoileron will move upward as well as the inner left one. Essentially, all the left wing elements will go upward. In a similar manner, when you continue to pitch downward, this time making a clockwise tilt and a right turn, the inner and outer right spoilerons will simultaneously go up. In other words, all of the right wing elements. Here is the circuit diagram for a fly-by-wire system. What's underneath that joystick? There are 4 push buttons that are 4-pinned, wherein any of those 4 buttons have a corresponding aileron to move either upward or downward. You need 4 resistors that are 10 kilo ohms in resistance so that we can create an active high switch, wherein by default, the push button is in off mode. But when it's pressed, it turns on. We have to put one battery that is 9 volts in voltage so that we can create an active high switch for these 4 buttons. Those red lines refer to the positive terminal, while the black lines refer to the negative terminal. After we have set up the battery, resistor, and push button, we will set an output for this fly-by-wire system using an integrated circuit that has 4 AND gates inside it. 1, 2, 3, and 4 refer to the output and input connections. They're physically connected, but to make it look cleaner in circuit appearance, we use triangles to represent those particular connections. We need another 4 push buttons that are 4-pinned so that the motor will not go on forever. Once it reaches its maximum deflection, either at the upward or downward most configuration, the motor will stop at a certain point. For these 4 push buttons, we will be using an active low switch that is on by default and off when it's being pushed, meaning that it has the reverse circuit of an active high switch. We need another 4 resistors again that is 10 kilo ohms in resistance to protect the push buttons from getting destroyed. We use push button triggered outputs for conditional motor spinning, as what I have said a few seconds ago, where the motor has a maximum upward or downward deflection to move those wings individually. We need a dual H-bridge motor driver so that we can move the 2 motors independently. We will attach 2 motors to this dual H-bridge circuit. And then the positive and negative terminals are connected down below. While those 5, 6, 7, and 8 connections refer to the 1, 2, 3, and 4 conditioned outputs. Because of that active low switch that controls the maximum deflection of the wings that are motored. Now, Let's test the fly-by-wire system that we have just created. First, let's start with an upward pitch, counterclockwise tilt, and left turn. Only the right flaperon will move downward and nothing else. When you pitch it upward, both flaperons will move downward. Again, the right flaperon will only move to a certain downward maximum deflection. But when you make a clockwise tilt and right turn, while still pitching upward, only the left flaperon will remain downward, and the rest of the wings are just retracted. Now the buttons, each of those four ones, have a specific assigned aileron to move. We push the forward right button on the northeast to retract the right flaperon. And then we put it back to its upward and pitched right mode, just like in a real Airbus 320 plane. When you make a counterclockwise tilt and left turn, and the pitch is just 0 degrees, the left aileron and left spoileron will simultaneously go up. The spoilers are mechanically raised, whichever aileron is beside it that is going up. Meanwhile, the right aileron just goes down on its own, and the right spoiler is retracted. This is achieved by moving the joystick to the left. That is, both buttons on the left side are being pressed at the same time. Similarly, when you make a clockwise tilt and right turn, the right spoileron and right aileron go up simultaneously, while the left aileron will go down on its own, leaving the left spoileron as is, retracted. This is achieved by moving the joystick to the right, pushing both buttons on the right side simultaneously. But when you make a downward pitch, counterclockwise tilt, and left turn, only the left aileron will move downward. But when you move it forward, the joystick, and also move it to the left at the same time, only the outer left and inner left spoilerons will move. In other words, both wing elements on the left side will be raised upward, while the right wing elements will just stay retracted. But when you pitch downward, all wing elements will raise upward, like a grand spoileron. Since the left spoileron and left spoilers are being raised up a while ago, they will not move any further more. Only the right spoiler and right spoilerons will raise up to catch up with the left wing element's position, upward maximum deflection. But when you make a clockwise tilt and a right turn in a downward pitch, that is, only the right spoilers and right ailerons will move upward. The right wing elements only move upward to reduce the speed on the right side. That is by pushing the joystick forward and to the right simultaneously, pushing the forward right button